Yeah, it's another time again. Today we are going to look at forms of energy. Now before I start, my names are Akasi Harrison and I'm your basic science teacher. Remember in the last class we talked on the meaning of energy and the source of what? Energy. But this class we are going to look at the forms of energy. The forms of what? Energy. Now we have different types of forms of energy. One is mechanical energy, two is heat energy, three is electrical energy, then four we have what? The chemical energy, then six we have a light energy, seven we have the sound energy, and lastly we have the what? Nuclear what? Energy. We are going to look at each of them one after the other, their definitions and their explanations. Now firstly, we are going to look at what is mechanical energy. Mechanical energy is the form of energy that a body possesses because of its what? Motion. Now, we have different types of mechanical energy. One, we have the kinetic energy, and two, we have the what? Potential energy. Now, let's look at what is mechanical energy. Mechanical energy is the energy possessed by a body due to its what? Motion. So, a body in motion possesses what we call kinetic energy. Now, a body moving, like you can see, has what we call what? Potential what? Energy. And the unit for this energy is also what? Joules, like I told you in our previous class. Now, the next form of energy we are going to look at is, let's look at the calculations on kinetic what? Energy. Now, to solve kinetic energy, we have different forms. We have a formula we use to solve for kinetic energy, which is Ke equal to half mv square. Ke equal to what? Half mv square. The m stands for mass in kilogram, while the v stands for velocity in meters per what? Second. Now, let's take a look at an example. A car of mass 30 kg is moving with a velocity of 10 meters per second. Calculate its kinetic energy. Now, to do this is very simple. What you do first to write the formula Ke equal to half mv square. Then you bring out the variables you need. The mass there is 30 kg, while the velocity is what? 10 meters per what? Second. Now all we do next is to say Ke equal to half times 30 times what? 10, and that will give us 150 what? Joules. Very simple, as you can see. Now very quickly, let's look at the next form of mechanical energy, which is what? Potential energy. Now, what is potential energy? This is the energy possessed by a body due to its position. Now, potential energy can also be called stored energy. Can be called what? Stored what? Energy. And now, the formula to solve for potential is PE equal to what? mgh. And don't forget the one for kinetic energy, which is Ke equal to half mv square. For this, the m stands for mass in kilogram, while the g is acceleration due to what? Gravity, and it's always 10 meters per second square. Now h stands for what? Height in meters. Now let's take a look at an example on potential energy. An example on potential what? Energy. Now, a body of mass 100 kg is released from a height of 10 meters per second square. Calculate the potential energy. Now what you do is to write the formula PE equal to mgh. Now the mass there is 100 kg. The g is what, 10 meters per second. The h is, which is the height, is 10 meter. Then what you do next is to multiply everything together, which is 100 times 10 times 10. That will give us 10,000 joules. Now in picture you can see that picture showing you some examples of mechanical energy and what, potential energy. Now the next form of energy we are going to look at is the heat energy, also referred to as what, thermal what, energy. Now this is the energy released when a substance is being burnt, e.g. like your petrol, your kerosene, your diesel, your coal. So when they are being burnt, it releases what we call what, heat what, energy. Now heat energy can be in one different ways. Heat energy can be transferred either by conduction, either by convection, and either by what, radiation. Don't forget that. Now let's take a look at the next form of energy, which is what, electrical energy. This is the energy generated when there is flow of electric current through a conductor. Through a what, conductor. Now we get this electricity. You know that without electrical energy, it's possible, this modern age, we need what, electrical energy. It's very important in our homes. Without it, a lot of things cannot be done. And we get this electrical energy from the power stations through transformer and through some other means. Now you can see some of the appliances we use using electrical energy, like your pressing iron, your TV set, your refrigerator. All these we use them using the word electrical what, energy. So electrical energy is very important in our modern life. Now let's look at the next one, chemical what, energy. Now this is the energy that comes when substances what, react together. This energy can be contained in the food we eat. It is also present in the dry cell batteries, which is used in our torchlights and all that. This energy is also very, very important. Now let's look at the next one, which is light energy. Light what, energy. And light energy is very important. It enables us to see. That light energy we can see in our homes at night, so it's very important. Now the major source, what is the major source of this light energy? The major source is what, the sun. The sun, and we have other sources of this light energy, like the fire, electricity, and all that. But the major source of this light energy is the what, is the sun. Now let's look at the next form of energy, which is the sound energy. Now this is energy that comes or produced when substances what, vibrate. When you talk to someone, release what we call sound what, energy. When a car horns, it releases what sound what, energy. So sound energy is the energy that is produced when substances what, vibrate. Now let's look at the very last form of energy, which is the nuclear what, energy. This is the energy that comes when the nucleus of an atom, such as uranium, undergo what, nuclear fission. When they undergo nuclear fission, an energy is released called what, the nuclear what, energy. Which energy is very what, important. Now this is where we come to an end, and I believe you have enjoyed this class so far. Our next topic will be what? Energy transformation. Thanks for watching, and don't forget to do your quiz, your assignments, and read for your what? Second test. God bless you. Thank you. It's not spoiled.